Alright class, so we're going to go off last class we started talking about evolution, and to better show evolution we're going to show an example video of antibiotic resistance by bacteria, and why bacteria are the best masters of adaptation.
So here's our short little video.
What if I told you there were trillions of tiny bacteria all around you? It's true. Microorganisms called bacteria were some of the first life forms to appear on Earth. Though they consist of only a single cell, their total biomass is greater than that of all plants and animals combined. And they live virtually everywhere, on the ground, in the water, on your kitchen table, on your skin, even inside you. Don't reach for the panic button just yet. Although you have 10 times more bacterial cells inside you than your body has human cells, many of these bacteria are harmless or even beneficial, helping digestion and immunity. But there are a few bad apples that can cause harmful infections, from minor inconveniences to deadly epidemics. Fortunately, there are amazing medicines designed to fight bacterial infections. Synthesized from chemicals or occurring naturally in things like mold, these antibiotics kill or neutralize bacteria by interrupting cell wall synthesis or interfering with vital processes like protein synthesis, all while leaving human cells unharmed. The deployment of antibiotics over the course of the 20th century has rendered many previously dangerous diseases easily treatable. But today, more and more of our antibiotics are becoming less effective. Did something go wrong to make them stop working? The problem is not with the antibiotics, but the bacteria they were made to fight, and the reason lies in Darwin's theory of natural selection. Just like any other organisms, individual bacteria can undergo random mutations. Many of these mutations are harmful or useless, but every now and then, one comes along that gives its organism an edge in survival. And for a bacterium, a mutation making it resistant to a certain antibiotic gives quite the edge. As the non-resistant bacteria are killed off, which happens especially quickly in antibiotic-rich environments like hospitals, there is more room and resources for the resistant ones to thrive, passing along only the mutated genes that help them do so. Reproduction isn't the only way to do this. Some can release their DNA upon death to be picked up by other bacteria, while others use a method called conjugation, connecting through pili to share their genes. Over time, the resistant genes proliferate, creating entire strains of resistant superbacteria. So how much time do we have before these superbugs take over? Well, in some bacteria it's already happened. For instance, some strands of Staphylococcus aureus, which causes everything from skin infections to pneumonia and sepsis, have developed into MRSA, becoming resistant to beta-lactam antibiotics like penicillin, methicillin, and oxacillin. Thanks to a gene that replaces the protein beta-lactams normally target and bind to, MRSA can keep making its cell walls unimpeded. Other superbacteria, like Salmonella, even sometimes produce enzymes like beta-lactamase that break down antibiotic attackers before they can do any damage. And E. coli, a diverse group of bacteria that contains strains that cause diarrhea and kidney failure, can prevent the function of antibiotics like quinolones by actively booting any invaders that manage to enter the cell. But there is good news. Scientists are working to stay one step ahead of the bacteria, and although development of new antibiotics has slowed in recent years, the World Health Organization has made it a priority to develop novel treatments. Other scientists are investigating alternate solutions, such as phage therapy or using vaccines to prevent infections. Most importantly, curbing the excessive and unnecessary use of antibiotics, such as for minor infections that can resolve on their own, as well as changing medical practice to prevent hospital infections, can have a major impact by keeping more non-resistant bacteria alive as competition for resistant strains. In the war against superbacteria, de-escalation may sometimes work better than an evolutionary arms race.
Okay, so based on this little video, we're going to have you do a quiz on socrative. So if you could log on to that and type in the room name, Andrews 1584.
When you're all logged in, you can just look up.
you put your last name and then your first name.
And please do last and first. It makes it easier for grading.
So I see some of you answered the first question already. So what leads to microbial resistance? One more. All right, Geraldo. So from this, after you ask a question, you can just give instant feedback. So you can just click on this little "How do we do" button. Everybody got it. Mutations.
Cool. So that was the main idea from the video. Basically, is that chance mutations in a bacteria's DNA is what would lead to it possibly having a genotype that would make it more advantageous, which would allow it to pass on its genes and make the whole population have that gene.
Great. So next one is, how do antibiotics work? They inhibit cell wall growth, killing off the bacteria cells and harming human cells, reverse osmosis, or chemosynthesis.
Just do your best. We're just trying to check what you got from the video, that's all. Isaac? Come on, brother.
Alright, so 60% of you got it, and it is inhibiting cell wall growth. So, B, while it does kill off bacteria cells, antibiotics don't hurt human cells at all. Not bad. Okay. So this one, you can kind of talk to your neighbor. One of you can submit an answer. So apply Darwin's theory of natural selection to microbial resistance.
So in the video, they mentioned that the reason that bacteria are able to evolve and become resistant to different antibiotics is because of Darwin's theory of natural selection. And in that theory, they basically state individuals with the best genes for survival are able to survive and pass on that trait to the next population. So how would that apply to these bacteria becoming resistant to different antibiotics? That's what the question is basically asking. It doesn't have to be more than a couple sentences, but you can just talk with the person next to you and just come up with a consensus answer. Then we'll discuss it as a class.
You guys don't have anything plugging in this table?
No.
And you'll see when the answers pop up, it doesn't actually show the answer unless you want to show it. So that way it kind of keeps some of the student answers anonymous. If you wanted to pause the screen, just do it as a teacher without the student seeing it, you can do that.
You can also have it show names so you can see who has answered and who has yet to answer.
So it really works well if you're trying to use it for yourself for grading purposes, like this was an actual quiz, or if you're doing it more for an informal discussion-based lesson. So I think that's all of our answers.
Okay, so then you can go through and we can talk about each of these answers and discuss it as a class as what's right with them, what's wrong with them, how can we improve them.
Just make sure they understood what the point of the question was. But it looks like they all had pretty good answers.
Alright, this is the last one. You can talk amongst yourselves again.
So same deal as the last one. Why are bacteria considered to be masters of adaptation? While the video didn't directly, hit on this point, there's many things that I did talk about that you can kind of apply to this and maybe lead to why that would be true.
beforehand, you can just look and see what the answers were. We could talk about it as a class, see how well they are. You can keep it to yourself if you're using it as an actual form of assessment. And that's it for these ones. And then you can head back to lunch, and then there's a little exit ticket that you can give your students. So you can bring it up here. This is what it says. And then the third question for this is student-based, so you answer them and then it moves on. It's not like the other one where I control which screen you're on. And the third question up there is, did you enjoy using Socrative? That will probably be a likely answer. High school students.
What was the question? It was, did you enjoy?
Did you enjoy using the, do you think this was a good formative assessment tool? That's basically that. So Socrative is basically just an online assessment tool that can be used to formally or informally assess students, lead class discussions, take actual grades for content that you've taught. You can create your own quizzes, you can edit them. Students don't even need an account for it. Teachers can get accounts for free. So students basically just log in with their name, and the teacher can see exactly who answered what they answered, and they can put that straight into the grade book or just discuss it with the classmates. So thank you for all of you coming out today and helping us out. And that's it. Anything else, Josie?
I think so. Thank you.